Hi girls, how are you? We're going to have a look today at the next step, I suppose, in our KC calculations. So I've put up a couple of clips already where you were asked to calculate KC, and hopefully you've gone and done that. I gave reference to a couple of examples in the textbook that you could try, and then there's a couple of examples in the past papers you could try. So you should do them first, because the next one's a little bit more complicated. And it's important that you can calculate KC and you know what KC is before we go on to do the next bit. Okay, and the next bit I'm just going to go straight into doing an exam question, if that's okay, because it's probably the easiest way. Basically, these calculations come in two forms. Essentially, they can either ask you to calculate Kc, or they can give you Kc and ask you to calculate the equilibrium concentration. So that's a little bit trickier, and that's what we're going to do today. It's not really trickier from a chemistry point of view. The maths is just a little bit more long-winded. Nothing you're not able for, just takes a little bit longer. Okay, so I'm going to go through that with you now. And as an example, I'm doing this one here. This is 2017, question 7. All right. So in question 7 in 2017, if you want to pause the clip and look at it, we're only looking now at the calculation. We haven't looked at Le Chatelier or any of that stuff yet. We'll do that next week. Okay, so for now, we're just looking at this. This is N2O4, nitrous tetroxide, gives us nitrogen dioxide here. We've got 1 mole of this in a 10-litre container, and we're asked to calculate the equilibrium concentration of both. Okay, so what does that mean? Basically, they've given us Kc, which is 0.2. That's in the question. You can see that. And we're basically asked to calculate this value and this value. So I'm going to try and show you how to do that today. All right. So we're going to start exactly the same as we did before. This is just the table drawn out. We have initial, we have used, we have the equilibrium amount, and we have the concentration at equilibrium. All right. And we're going to start. I've just written for myself that equation that you've just seen over there in the corner. Remember, I'm raising this to the power of 2. And that's equal to 0.2. So I'm basically looking for these two values today, all right? So the initial value, the initial amount of N2O4 is given as 1 mole in a 10-litre vat, okay? And I know nothing else, right? So I don't know anything else. So because I don't know anything else, what I'm going to do is I'm going to look at my equation here, and it tells me that one of these gives me 2 of these, right? That's all I know. So I can assume that if the amount used of this is X, well, then the amount produced of this at equilibrium is 2x. Does that make sense? So you can see what we're doing. We don't know any numbers, so we're using x to represent values we don't know, and later then we'll go back and calculate x. All right, but for now, we know that x of this got used up, 2x of this got produced. So that's what I'm going to write in my table. And now I can figure out that the amount of N2O4 that was actually used in the reaction, that was left at equilibrium, left at equilibrium is whatever was there at the start minus what got used up, which is 1 minus x. See what I'm done? Yeah. And then the last step is to change this to concentration by dividing by the volume. It mentions in the question that it was done in a 10-litre vat. So that means that the concentration of this is going to be 1x minus 10. Sorry, not 1x minus 10, 1x divided by 10. And this one's going to be 2x divided by 10. So I've done that there. Can you see that? 1x divided by 10. 1 minus x divided by 10, and then 2x divided by 10 there. All right. So this is my concentration at equilibrium of NO2. This is my concentration of equilibrium at N2O4. And basically now what I'm doing is maths. Okay. I'm plugging these values into here and solving for x. Okay. So the chemistry bit is done. We're now doing the maths. So I'm just going to write this equation here. So I've got 2x divided by 10 squared. See that? Yeah. And then I'm going to divide all of that by 1 minus x divided by 10, and that's all equal to 0.2. Like that. See what I've done? So that's that bit, and that's there. And literally now, all I have to do is solve for x. Now, if it's okay with you, I'm going to move onto paper here because this is just, it's too messy and it's taken me, I'm going to need too much whiteboard to actually go through this. So I'm going to switch to paper here if that's all right. And we're going to go through how to do each bit of this. All right. So this is the equation rewritten. As you can see, I've got 2x divided by 10 over 1 minus x over 10 equals 0.2. Now, all this is from now on is maths. I'm trying to simplify this equation. Obviously, here it looks horrendous. So I'm going to simplify it and I'm going to find x. And that's pretty easy to do when we do it step by step. Right. So the first thing that I'm going to do is I'm going to get rid of these fractions. I don't like them. Okay, so I'm going to get rid of these fractions. So what I'm going to do is, as you can see here, I'm going to multiply out the top, which is 4x squared, and then I'm going to multiply both above and below by 10. So that gets rid of the 10 at the bottom. Can you see that? So 1 minus x divided by 10 multiplied by 10 is 1 minus x. 4x squared over 10 squared multiplied by 10 is 4x squared over 10. Right? Now life is a little bit easier. I can bring this over to this side of the equation and multiply it out. So I'm going to do that. So now I've got 4x squared divided by 10 equals 0.2 multiplied by 1 minus x. Can you see that? So I've brought that 1 minus x over to this, and now I'm going to multiply that out, 0.2 multiplied by 1 minus x, and I get 4x squared divided by 10 equals 0.2 minus 0.2x, like that. And now I want to get rid of the last fraction here, which is 10, so I'm going to bring this 10 over here and now multiply that by this side. All right, do that, and I get 4x squared equals 10 times 0.2 minus 0.2x, like that. Okay, now I'm going to multiply this out here, and I get 4x squared equals 2 minus 2x. All right, see what I've done? So you can see where we're going with this. We're going to end up with a quadratic equation that looks like this. You're familiar with this from maths. 4x squared plus 2x minus 2 equals 0. And we're going to use our formula, minus b plus or minus the square of b squared minus 4ac over 2a, that should be, which is available in your tables book, but which I suspect you probably know already from using it, okay, to solve quadratic equations. So hopefully you're familiar with this. This is A, this is B, this is C, and literally now I just plug in my values. I need to be careful about signs and stuff like that to make sure that I don't make a mistake. Plug in my values. I will get two values. Only one of them will be possible. Okay, we'll talk about that when we get to it. So now I'm going to put my values in here like this, and this is what I get. I get minus 2 plus or minus the square root of 2 squared over minus 4 times 4 times minus 2, and that's over 2a, which is 8. I should have put 8 down the bottom there, like that. All right, when we multiply this out, minus 4 times minus 2, we get 4 plus 32. All right, add them together, we get 36. So we've now got minus 2 plus or minus the square root of 36 over 8. Square root of 36 is 6. I'm just going to switch over here. So we've now got minus 2 plus or minus 6 divided by 8. Now, at this point, we've got two options. Remember what we're looking for. We're looking for a concentration. We can't have a negative concentration. So obviously, minus 2 minus 6 gives us minus 8 over 8, which is minus 1. That's not possible. We can't have a minus concentration, so it has to be plus 2. You'll always have one value that's possible, one value that's impossible. It'll either be a negative number or it'll be bigger than the initial concentration, so it won't be a whole lot of use to you. So it's very obvious here what's the value that we're going to use. It's going to be plus 6. So minus 2 plus 6 is 4. 4 divided by 8 is 0.5. So I've found x. X is 0.5. And just a reminder what x is, go back to our table. X is the concentration of N2O4 that was used up. Okay, so that's 0.5 moles. And the question asks me to calculate the concentration of N2O4 and NO2 at equilibrium. So now I need to find what the value of this box is and this box is, given that x is 0.5. So that's really easy to do now. The concentration of N2O4 at equilibrium is 1 minus 0.5, which is 0.5 moles. And the concentration of NO2 is 2x, which is 2 times 0.5, which is 1 mole of NO2. All right. So that's the next type that we need to do. I'm going to do another couple of examples for you and stick them up. A little bit more long-winded from a maths point of view, but not any more difficult from a chemistry point of view. Okay, so hopefully with a little bit of practice, you'll find them easy enough, and hopefully that was helpful. All right, thank you. Bye-bye.